Good morning, everyone. Today we are going to continue our practice solving for x, but this time we're going to throw a wrench in the works because unlike before, where we found x is equal to a lovely number like 5 or 4.2 or something like that, this time we are not going to have x equal to a number. What we're going to have is x written in terms of other variables. Now, if you don't know what that means, don't worry about it. I'm going to show you here. Let's start with this example problem. I want to solve for x, but what I've been given is z plus x is equal to t. Now that's a bit of a problem because I don't have any numbers to move away from x. So if I'm going to solve for x, what on earth could x be? Well, let's think about this in a problem that you're used to seeing. So for instance, let's say I was trying to solve for x. And in doing so, what I had was a number added to x, right? Because z here is just a number. So let's pick a random number. I'm going to do 110 for z. And let's say that I knew what t was, and I said t was 325, right? I don't actually know what these numbers are, but I'm just going to throw some numbers in to see how I normally solve for x. Well, normally in order to solve for x, I would move the numbers away from x and to the other side. So I'd subtract 110 from both sides. And that would tell me that x would have to be equal to 215. And I would be done. Now, think about it this way. What I've done is the process that I want to do on this equation. So in order to solve for x or get x by itself, what I'm going to do first is I'm going to move everything away from the x. And don't forget that x, or that z here, the thing that I want to move away, is a number just as surely as 110 is a number. So just like in order to get rid of the 110, I subtracted 110. To get rid of the z, I'm going to subtract z from both sides. Now that does wonderfully leave me with x alone on the left side. However, on the other side, it's a bit of a mess because, well, we could in our example problem subtract 110, which I wrote as 100 for some reason. Well, we could subtract it before. This time, since I don't know what z is, I'm not going to be able to subtract it from the t. Those are unlike terms. So that means what's really on this side is t minus z. My original t minus z. And I can't really simplify that. I can't combine those unlike terms. So I end up with an answer that is messy. It's x is equal to t minus z, which, by the way, would be a bit like saying x is equal to 325 minus 110. It's just another way of writing x is equal to 215. So one of the key things that you're going to have to watch for is as we move into equations that have more variables than just x, if you only have that one equation, you will not be able to get a number for an answer. You will have letters still in your answer. So don't be afraid to have something that looks a little messier. And we'll see how to check these in just a little bit. But first, let's do a few more example problems. So in this example problem, I want to solve for y. In other words, I want to get y by itself. And I know that 2x plus 5y is equal to 15. Now remember, if I'm trying to get y by itself, I'm going to solve this like I would normally. I will have an answer that is not a single number, and I know that because there is a variable besides y in the single equation that I have. So what I'm going to do is I'm going to start as if this was a normal number. 2x, remember, is just a normal number. We just don't know what x is. And typically what I do first is get rid of all of the addition and subtraction surrounding the y. So I'm going to subtract this 2x so that it disappears from this side. And on this side, I'm left with 15 minus 2x. Now, just get into the habit of this. It is nice to start with that negative 2x that we have there and do the plus 15. If you have it the other way around as 15 minus 2x, that's also correct. But there's something that we're going to do later that makes this just a little bit nicer. So on our left side, we're left with 5y. So here, I have 5y is equal to negative 2x plus 15. And I'm supposed to solve for y, right? Well, I'm not quite there because y still is not by itself. So what I need to do is I need to get rid of the 5. Well, we've done that before. All we have to do to get rid of the 5y is divide by 5 to undo that multiplication. And remember, I have to do that to both sides. Now be careful here. I am dividing everything on the right side of the equation. So that means when I find my y equals, I'm going to have to divide both this negative 2x by 5 and this 15 by 5. And that's because division kind of distributes over addition in the same way that multiplication does. So you're just going to divide every term. I like to think about it as the heart. As soon as you guys see, like 1 plus 2 over 3, you are going to do this little heart around the two terms that are added or subtracted there. So here I'm left with negative 2 over 5 times x, and you can write that way, plus, well, what is 15 divided by 5? Well, that's 3. So I end up with y is equal to negative 2/5 x plus 3. That would be my final answer. And I know it's my final answer, even though it's not a single number on the right side. I know it's my final answer because y is by itself, and I haven't lost my other variable, right? Because when I have those two variables, I won't get a normal number. So I'm going to do this a few more times with a couple other example problems. Let's take this one for example. I have 2j plus 5 is equal to k, and I'm told to solve for the indicated variable. And the indicated variable here is j. It's that one that's just like put off to the end there. So I want to solve for j. I want to get j by itself. So once more, I'm going to look at my original problem, and I'm going to try to move everything away from the j. So let's start by doing what we normally do. Normally, I subtract 5 from both sides. Now here, that leaves me with my 2j without that additional 5 tacked on at the end. But on this side, on the right, I can't actually combine the k and the negative 5, so I'm left with k minus 5 on that side. I'm keeping the variable in the front and keeping the negative with the thing that I subtracted. Now in order to get j by itself, my goal, I'm going to divide by 2. That undoes that multiplication, leaving me with j is equal to, well, I want to divide this side by 2, but I have this situation where there's a plus or minus in between two terms. So I'm going to have to do that little heart method, right? So I'm going to take the k divided by 2, and don't forget that in front of this k is a little hidden 1. That means what I really have is 1/2 k. And I'm also going to take this 5 divided by 2 and negative 5 divided by 2, and that's going to give me a negative 2.5. So my final answer is j is equal to 1/2 k minus 2.5. And that would be the end of this problem. Notice, just like before, I have my variable isolated or by itself, and I have a bit of a messy thing on the other side. Again, that's totally fine. So let's look at C. On C, I have 3x plus 2x is equal to t, and I want to get x by itself. Now, when I'm looking at this one, notice that on this side of the equation, I have two x's. They aren't different variables. They're the same. That means I can actually combine them. 3x plus 2x I can simplify and just write 5x. And that is equal to t on the other side. Here, when I want to get x by itself, my goal, I'm going to divide both sides by 5 because that's the only thing that I need to do to have x entirely by itself. And that tells me that x is equal to t over 5, or 1/5 t. And you can write it either way. I don't mind which one you pick. For b here, I want to solve for x again. And what I'm going to be doing for this one is I'm going to walk through this in just a moment, but I'd like you to try to solve it first on your own. So go ahead and pause the video and then start back up when you think that you have the right answer. All right, here's how I would go about this. Now, there are actually two ways that you can go about it, but since we're kind of used to getting rid of parentheses using distribution, I'm going to start with that one. I'm going to distribute this 3 to everything inside the parentheses. That gives me 3x plus 6 is equal to y. Now, I want to get x by itself. So I'm going to move everything away from the x, which means I'm going to be subtracting 6 from both sides to get rid of the addition and subtraction. That leaves me with 3x on the left, and on the right, oh, I am stuck again. I cannot combine the y and the negative 6, so I'm going to leave that as y minus 6. Again, I like to keep that variable in the front. The next thing that I need to do is I need to get y all the way by itself by dividing by 3. Again, I'm stuck in this heart situation where what I'm going to have to do is divide both the terms stuck over here. And don't forget that there's a hidden 1 in front of the y. That means that my final answer should be x is equal to the 1y divided by 3, or 1/3 y, plus a negative, 6 divided by 3, which is 2. Or I could write x equals 1/3 y minus 2. Now, you may have done this in a slightly different order. You may have first divided by 3 to get rid of that multiplication, and then subtracted by 2. That is actually the same answer. In fact, this formula can be written this third way, y over 3 minus 2, and that would be another correct way, or same way of writing that equation. If you got any of these 3 answers, it means that you did the problem right, and congratulations on that. Today you do not have any homework. Tomorrow we're going to do another instructional video on this sort of stuff, because this stuff does take a while to get used to, and I'll have a few problems for you to solve at that point in time. But all you have to do today is hit submit. Your lesson is done.